All right. Is there a specific problem? I think you can actually write on this, Christine. Let's see if you can write on that. Is it going to let you?
Yeah.
Yeah, you go. It's going to let you.
Okay. Answer by the tip.
Okay, that's I'm not any better. You're doing better than I would. And I have a stylus.
I'm using the mouse.
Well, it's got a bunch of them, don't it?
That's the question.
Okay. All right. Well, there's two rules that we have that's got mixed up in here. It's the quotient rule and the product rule. And let me write them over here. Let's say if we have the log base b of m, some number m, plus the log base b of n, then that is the log base b of the product m times n. That's called the product rule. Okay, so if you add two logs, it's you can take the log of the product of their two inputs. Now the quotient rule says if you have the log base b of m minus the log base b of n equals the log base b of m divided by n. So you could probably understand why they call this one the quotient rule. And what we have here is basically a product rule. That's the plus, that's going to be the product rule. And we got two minuses. So that's going to be a quotient. So let's take this one at a time. I could do this all in one step. And I'm going to show you how to do it step by step first, Christine.
Okay.
And then I'm going to show you Gary's easy way. How's that?
Yeah, that's good.
Okay. So the first thing is it's the log of x times x squared minus 64, because log plus a log is the log of their product. Then I'm going to write down the minus the log of 6 minus the log of x plus 8. Okay. Then, so what I've done was I've got these two right here and I put them together into that. The other two I just wrote down, whoop, and whoop, just wrote them down. Okay. Then I'm going to use the quotient rule once. Okay. So it's going to be the log of x times x squared minus 64 divided by 6. Okay, because that minus means I got to use the quotient. And this log of x plus 8 is just going to come down. Okay, so what I did was I applied the quotient rule because of that minus right there. So log of x times x squared minus 64, that x times x squared minus 64 is kind of like the m, and the 6 is like the n. So the 6 is going to go in the denominator, and that whole ugly mess, x times x squared minus 64, goes on top like the m did. Okay, and I still haven't dealt with that log of x plus 8. So again, that's going to be another minus there, so it's going to be another quotient rule. So it's going to be the log of x times x squared minus 64. And since 6 was in the denominator, so will the x plus 8. okay? And now the only thing left to do is to simplify, if it can. X squared minus 64 is a difference of squares, x plus 8 and x minus 8 over 6 times x plus 8. Now this, what I'm doing here is just math 103 stuff. It's just canceling, reducing. So log of x times x minus 8, and you can multiply that out if you wish. You don't really need to. I probably wouldn't do it. I'd just leave it factored over 6. And these big parentheses right here, Christine,
Yeah.
I don't need those, but I write them in there anyway.
Okay.
So, so now understand, I'm using a generic b over here because as long as the base is greater than 0 and not equal to 1, it can be any number. In this particular problem that you're choosing, the base is 10. All these are base 10. You're like, how do you know? It doesn't say that. Well, if you looked at the videos, if there's no number down there, it's assumed to be 10. And people ask, well, how do you know it's supposed to be that? Well, same reason if I have right here, for example, if I have 3 times x and I ask you what the coefficient is, you'd say, oh, it's 3. But if I just say x, what's the coefficient in front of that one?
1.
1. But I don't see a 1. How do we know it's a 1? You're right, it is 1. It's understood to be a 1. So even though you don't see the 1, you know it's a 1. Same thing down here. If there's no base down there, you don't see the base, you just know it's base 10. That makes sense?
Yes.
Now let me show you how to get from here to your problem all the way down to that level right there in one step. You ready? Okay.
Yes.
I have 4 logs in this problem. Okay. So what I do is I look in front of the log, and if it's got a plus in front of it, the input is going to go on top. If it's a minus in front of it, it's going to go on the bottom. So we got log of x, so the x goes on top, plus the log of x squared minus 64. Since it's plus, the x squared minus 64 is going to go on top. Now it's a minus the log of 6, but it's a minus, so that number, its input, will go on the bottom. So basically, I'm just taking the quotient rule and the product rule all in one stride. And then the next one, last one's a minus log of x plus s is a minus, so that x plus 8 will go into the denominator. So I did it all in one stride. And then once you get to that point, then you reduce like we want to go. So in other words, these 2 steps right here, the first 2 steps that I did is really unnecessary.
Okay.
But you know, I did it there because really technically that's what you're doing. I'm just doing what we call a shortcut. So
Yeah.
I'm just applying the rules one step at a time. And when I did this right here, I applied both rules on all 4 of those simultaneously. So you got to really know what you're doing if you do that, though. So if I had log base 3 of x minus the log base 3 of y plus the log base 3 of z. Now notice that all the base is 3, just like this one was base 10. Can you tell me what I'm taking the log base 3 of, and what goes in the parentheses? Tell me what goes in the parentheses.
X
Okay.
plus no, x times z.
X what?
X times z over y. Right?
What's the sign in front of the log base 3 of x? It's plus, right?
Yes. Yeah.
So it goes on top.
Mm-hmm.
Now log base 3 of y, it's got a minus, right? So where does the y go?
Down.
Down. Now plus the log base 3 of z. Where does the z go?
Up.
Up. And no, it's not plus. It's not x plus z. It's x because
Oh, yeah.
everything is in the form of a product. If you notice over here, it was x times x squared minus 64 and 6 times x plus 8. So everything gets multiplied, even whether it's in the numerator or denominator. So that's. Okay.
Yes.
So I wanted to do that one because the minus came before the plus. And I was wanting to show you what happens now. You can do it in one step. So the first one, the plus minus minus, this one's got a minus then a plus.
Yeah.
So what if I, Christine, what if I did this to you? At the end of this, I put a minus the log base 3 of w. Where do I put the w?
Down.
Down. Yeah. So it goes right beside the y down the bottom. See what I mean?
Yeah.
All right. Anything else?
Can you do like some from the homework, the paper and pencil quizzes?
Say again?
Could you do some from the paper and pencil quizzes that we have, a quiz?
Which one?
3.4.
3.4. Oh, okay, you're already on 3.4. Okay. Let me find it. Which one? Part 1?
Part 2.
Part 2. Okay, which problem?
Number 3.
Number 3, is it A or B?
Any.
A. All right. So here is, let me clear this first. Are we through with this?
Yeah.
All right, hope so, because I just deleted it. Okay, so this is 3.4 part 2, problem 3A. Okay, so we have log base 7 of x minus 6.
That's a 2.
Oh, okay. My glasses on. Yeah, you're right. Thank you.
Mhm.
Okay, log base 2 of x minus 6 plus log base 2 of x plus 6 and it equals 4. Okay, so we're trying to solve a logarithmic equation, it looks like. So solve the logarithmic equation. Be sure to reject any value of x that is not in the domain of the original logarithm expressions. Give your answer an exact answer. So in other words, don't use a calculator. Then, or should I say then, where necessary, use a calculator to obtain a decimal approximation out to 2 decimal places. So we're looking for 2 answers, the exact answer and a 2 decimal approximation if we need to, okay? So I'm glad you asked that other problem a while ago, Christine, because it sets the stage for this problem. In order to solve a logarithmic equation that has 2 of them in it, you need to condense into 1. Okay, so you need to make sure, hold on. All right, so what I'm going to do now is I'm going to put these two together. So it'll be log base 2 of x minus 6 times x plus 6 equals 4. And we did exactly what we did a while ago with the product rule. This is log plus a log. So it's the log of the product. There's no denominator because there's no minus. Got it?
Yes.
Well, then there's a rule of logarithms we learned back in, we did 3.2, that if you had log base b of x equals y, then that means b to the y equals x. And it works both ways, actually. So this one, b, the base is 2, so it's going to be 2 to the y, which is 2 to the 4th. And that is equals to x squared minus 36. Because x plus 6 times x minus 6 is x squared minus 36. Now 2 to the 4th is 16. And now it's just a matter of isolating the x. So just add 36 to the left side. So 36 plus 16 is 52. And then, so x is equals to plus or minus the square root of 52. Okay?
Yeah.
Now, square root of 52 can be simplified into a different version. 52 is, what is that?
It's 4 times 13.
4 times 13, you're right. 4 times 13. So then that's going to be plus or minus 2 square root of 13. Now, that's two answers. Okay? Positive 2 square root of 13 and negative 2 square root of 13. Now, I don't have my calculator with me, but in order to take what the square root of 52 is, I know it's more than 7. It's 7 point something another. What was it? Did you get that one?
7.2.
7.2. This should be one more decimal. I think we got to go to 2 decimal places. 7.21. 1. Okay.
1.2111. Yeah.
Okay, so 7.21. So then it's going to be x is equals to plus or minus 7.21, which means that this one's going to be 7.21 and this one's going to be a negative 7.21. And you're like, well, we're good. So we're happy. Well, the problem is you cannot take the log of a negative number. Now, just because the answer is negative, now this is very important, guys. You can't discard an answer just because it's negative. You're like, well, you just contradicted yourself. No, I didn't. I said that you cannot take the log of a negative number. Your x being negative doesn't necessarily mean you're taking the log of a negative number. It is in this case because if you take negative 7.21 minus 6, that's going to be a negative 13.21. And then you end up taking the log base 2 of negative 13.21. And you can't do that. So that one you discard. Now 7.21 minus 6 is 1.21, and you can take the log of 1.21. And then 7.21 plus 6 over here is 13.21, and you can take the log of that number as well. So a lot of people mistakenly believe that just because the number is positive, you keep it, and just because the number is negative, you throw it away. You've got to make sure, because I've seen positive numbers you got to throw away. I've seen negative numbers that you can keep. So, I mean, probably 90% of the time, that's the case. Positive numbers you keep, negative numbers you throw away. But there is exceptions, depending on how the problem is set up. So, you just cannot take the log of negative numbers. So,
Check.
log base b of a negative number, not okay. Not. You can't do that. Okay?
Yeah.
And so, let me show you what I'm talking about. I'm not going to solve a problem. I'm just going to show you what I'm talking about. If I have log base 3 of x plus 4 and some other junk, and it turned out that x was equals to a -2, and if you solve the equation and x equals -2, see, number's negative. But when you put -2 back in, -2 plus 4 is 2. And log of +3 of 2 is fine. And -2 would be a keeper. You could keep it, and it's negative. So sometimes the answer is negative, but it doesn't cause a problem up here. So a lot of people, like I said, mistakenly think that if your answer is negative, you automatically throw it away. And that's not true. Okay?
Yes.
All right, anything else?
I don't have.
I think Haley is good, Christine. So if you, we're counting on you to ask questions here. And if you don't, then I have to go to Chris, but he's muted. So. So has anybody looked to see what homework assignments, what sections we're doing this week? I hadn't looked yet. Is it 3, 4, and 3, 5? Was I right last time I taught? Was it 3, 4, and 3, 5?
3.3 was due 2 days ago, but
Right.
it's 3.4 and 3.5, I think.
Yeah,
Yeah,
it's just 2.
It's those 2 sections. That's what I thought. And I think 3, 4 has 2 parts, and 3, 5 has 1 part.
1.
So, and then it's downhill. Chapter 7, we don't do chapter 4, 5, and 6 in this course. So the next thing we do after chapter 3 is 7, 1, and 7, 2. I mean, we're closing in on the end of the material. So can somebody tell me what was when I was talking to you guys last time about the logarithms? I mean, whether you know what all the rules are yet or not, it's important that you know what the purpose of them are. Otherwise, you're doing them for nothing, because you can encounter a problem, you don't know what to do with it. If you know what the purpose of logarithms, it's helpful. So can somebody remember what I said last time about logarithms? What's the purpose of logarithms?
To resolve exponential equations.
Yes, because exponential equations, well, exponential functions and logarithmic functions are
Functions.
Yes. So if you remember back in 1.8, we did inverses. And and then that kind of set the stage of what inverses do. Remember, what the inverses do is if A gives me B in the original function, then in the inverse function, B will give me A. So it just goes reverse. So if you have F and G, they're inverses. If F of 5 is 10, then G of 10 is 5. It just reversed. Well, exponentials work the same way, and logarithms has the same relationship. If you put 2 into an exponential function and you get 9, and if the logarithm is if a certain logarithm is its inverse, then the 9 would give me the original number. I think I said 2. So if 2 gives me 9 in the exponential function, then the logarithmic function 9 will give me 2. So that's the idea of that relationship. So it all, it's the same problem I showed you last time. You know, if I said, I'm not going to write the same one I did last time, but if I had, for example, 3 to the x minus 1 equals 17. Now, we know 3 squared is 9, and we know 3 cubed is 27. But 17 is in between these two numbers. So we know this exponent needs to be between 2 and 3. So we know x minus 1 is between 2 and 3. Okay, but you're like, well, that doesn't give you the answer. All you know is the x minus 1 is between 2 and 3. That's true. That's all I know, unless I invoke a logarithm. Well, the logarithm is log base 3 of 17 equals x minus 1. And then add 1 to the other side, and that equals x. And now all I got to do is get my calculator out and evaluate that. And that number, I guarantee you, will be between 2. Well, actually, it's going to be between 3 and 4 because there's an x minus 1 there. So log base 3 of 17 is going to be 2 point something, and then plus 1 will be 3 point something. But when you go back and subtract 1, it'd be between 2 and 3.
3.5.
How much?
3.58.
Yeah. So, and then we show, she said 3.58. So if you take that number, and we won't get exact because she gave me an approximation. If you take 3 to the 3.58, you said that, right? Minus 1.
Yeah.
Because it's got a minus 1 after that. That's going to be 3 to the 2.58. Now, do you know how to do that on a calculator?
Yeah.
I'll do it. 3 raised to the 2.58. See what you get. I guarantee you won't get exactly 17. But
Yeah,
you'll get in the vicinity. What is it?
It's 17.02.
And why did we not get exactly 17?
We have to round off.
Yeah, because you estimated. You rounded it to 3.58. And every time you round, if you'd have kept every one of those numbers without rounding, of course, we'd had a long string of numbers in the exponent. But at the more string of numbers you had listed there, it would give you something closer and closer to 17. So, I mean, think about what this is all about. I mean, back in the day, when we had stuff like this, 3 times x plus 5 equals 17. That was back math 101. So you just apply the inverse operations. You subtract 5, be 3x equals 12. I mean, these were the good old days, right? Divide by 3, x is 4, because you know the inverse operation of plus, and then you know the inverse operation of times is division. Okay, so that was the good old days. But back in math 103 or 101 or 103, if some teacher gave you this one, you might be able to do that, because that's 3 to the x plus 2 equals 3 to the second. And so then x plus 2 equals 2, so x equals 0. But the only reason you could do it is because the 9 and this base can be made the same number. So 9 is 3 squared, and so the exponents must be equal. But the bottom falls out when this happens. 3 to the x plus 2 equals 15, for example. You cannot make 3 and 15 have the same base, no matter what you do. You can't make it look like this one. You can't make it do that, because 9 is 3 squared, but 15, you can't really do it. So what do? Well, you can do what I did over here, but you could also do something else. You could take the log of both sides. Okay, and then you can use the product rule, which is the same rules as the quotient rule, and bring it out front. So it's going to be x plus 2 times the log of 3 equals the log of 15. And then it's going to be the x plus 2 equals the log of 15 divided by the log of 3. I just divided by the log of 3. And then finally, move the 2 to the right side. So x equals the log of 15 minus the log of 3 minus that 2 out there. Just take that 2 and subtract it over there. So, and there you go. There you are. So, yeah, but that's different than how you did it up here. I know. You can do it 2 different ways. I'll show you the way we did it over here by the same technique. 3 to the x plus 2 equals 15. So this was going to be the log base 3 of 15 equals x plus 2. And then subtract 2 to the other side. So it'll be log base 3 of 15 minus 2 equals x. And you're like, well, that's not the same answer. Oh, yeah, it is, because the log base 3 of 15 by the change of base theorem, which you'll learn in 3.4, is the log of 15 divided by the log of 3 minus 2. So it is the same answer. This change of base. So that's something you're going to need to look at in your video. Change of base. Has anybody seen it yet?
Yeah.
Okay, so the change of base theorem. So, you know, in some ways, this is probably the one of the easy things that people can do. There are a lot of rules, and you got to know the rules. But the reason people struggle with logarithms is simply because it's new. You know, if I gave a test to you, I gave you 3 times x plus 5 equals 17, like I have in the middle of that screen there, you guys would love me, okay? But that'd be not math 136. That would be math 101. Okay, so we just have another type of equation to isolate the x in than what we had in math 101. Like 3 raised to the x plus 2 equals 15. That's a math 136, and the math 101 student has no hope of doing that. So, unless they've done logarithms. But yeah, the logarithms, their purpose is to solve these types of exponential equations. That's why we do them. So, you know, it's like, you know, if you have an exponential function, let's say if a graph looks like this, and it looks like this, you know, I'll start it over here at the y-axis, and then the graph goes, and then it just goes up. That's exponential. And I'm going to show you why we do this. Okay, let's talk about the pandemic. I'm just using examples. Okay, this function that they created turned out to be, and they did this by an exponential model, and it was let's use n for the number of cases. N of x is equals to let's say 1600. This might be some state times e to the let's see, 16 times e to the 0.03x. So we have a 3% increase rate there. So now, so that means when this thing began, there were 1,600 cases. When they did this experiment, this model, there were 1,600 cases. But from then on, it was growing exponentially at a rate of 3%. Now, I might want to know if this is x, and this is the number of days from the beginning. From the beginning of the pandemic. I don't know, maybe this is Alaska or something like that. I don't know, maybe it's one of those, it's definitely not New York. It's one of those states that has a very few coronavirus cases. But maybe I want to know, guys, when what day will the number of cases reach 40,000? When will it reach 40,000? 1,600 at the beginning. When will it reach 40,000? What day? What day will it hit 40,000? Well, this is kind of what's going on. Come out here, and then that number is right there. Is whatever that day is right there. Now you're like, well, I can't tell you what that is. I know I can't either just by looking at it, but you can do it by solving that equation. So you would have, 1,600 e to the 0.03x equals 40,000. And you have to solve for x. So the first thing you would do is you would divide by 1,600. So then that's e to the 0.03x equals 40,000 divided by 1,600. Well, I don't know. But a couple of these zeros on the end cancels out. So I don't have to deal with those. So it's 1,600. So it's going to be 400. I just don't have a calculator. So 1,400 divided by 16, which is what?
25.
25. Okay, good. Okay, so it's 25. Now it just, simplifies down to the same type of problem that I had over here. So instead of doing it, well, I can take the log of both sides, but I can also change it to the log base e of 25 equals 0.03x. So what is log base e? Does anybody remember? Log base e, what is that? Remember, it's those two words, but it's not the way you sound it. It's because in some countries it's said a different way.
Natural log.
Yeah, natural log. So we got the natural log ln of 25 equals 0.03x. So x is equals to the natural log of 25 divided by 0.03. Okay? So what is that number?
It's 10.72.
How much?
10.73, so 10.
10.73. So it looks like I'm about to the 11th day. So on the 11th day, that's when it hits. Oops. On the 11th day is when it reaches that number. Does that make sense?
Mm-hmm.
So, and you think about it, without logarithms, you have no hope of doing this. Some people would say, well, can't you just put 1 in, put 2 in, put 3 in, put 4 in, put 5 in, until you get 11 and see if it hits that 40,000 mark? Well, you probably could if you had a lot of time on your hands. And you definitely would not get exact of an answer as 10.73, because 10.73, now 0.73 is going to be the 10th day and 0.75 of another day. So it's going to be 6 p.m. It's going to be around 6 p.m. on that 11th day. Because 0.73 is about 6 p.m. So you do a 24-hour thing, 75% of 24 hours is about 18 hours. So 18 hours from midnight is going to be 6 p.m. on that same day. So, do you want to be that accurate? I don't know. But I'm just saying this is kind of, what you do if this is why you solve these types of equations, because you're basically are being given the output of the exponential, which is 40,000. You're given that, and then you're trying to figure out what the input is, in other words, the x, is based on that output. So you have to turn it around So you're taking the log of an input, which was the output of the other one. So, but that's the idea. So it's basically gives you the ability to turn it around. So you're taking a input of a number. So E.03x, x is the input, but I can't tell you what that is because they didn't give it to me. So, but anyway, I mean, I just made a problem up. I mean, this is not, you're not going to find this anyway. It just came out of my head just right now. But this problem right here, this thing to work. That problem. I mean, if I was going to put it in a nutshell, somebody asked me, what do you do logarithms for? I mean, this is kind of the idea. I mean, they get little, you can make it a lot more complicated than this one. But this is probably the easiest way I can give you to give you the purpose of what logarithms are for. So, okay.
Yes.
Anything else?
Nope.
No, I'm good.
You're good? Hey, Christopher. You gonna talk to me, buddy? Let me unmute him. He's muted. He doesn't want to talk. So, he's not want to talk to us. Okay, that's fine. So, so 3435. By the way, I sent you guys an email. Did you get it right before the session started?
Yes.
Okay. What the email said, Haley, was that, and Christopher, was that next week I'm going to go ahead and meet this Friday, like we normally would meet. But starting
I saw
next,
the email.
oh, you saw it?
Mm-hmm.
Okay. So starting next week, Tuesdays and Thursdays, same time, 8 o'clock, but we'll probably go a little, we'll bleed over to about 9:30 if we need to. I'll still try to do 3 hours a week with you guys. But I'm just not getting any, I mean, 2 or 3 people, 3 days a week. I was hoping when I started this whole process, somebody asked me, well, how do you think how many people you're going to have? And I'm thinking, okay, I have about 70 students now through my classes. There's 70 altogether. I would be happy with, 15. I thought 15 was a good number. And I'm only getting 3 to 5. And Haley is here all the time. Christine, you are too. And Christopher is here most of the time. But I mean, you guys are just, you're good. You're coming. But, I'm just hoping for 12 more people at least. But I guess we're all good with that. So, but anyway, so you got okay? You guys are okay with the Tuesday, Thursday?
Yes.
Yes.
Okay. So, but anyway, and I think the Tuesday will help anyway as far as the Tuesday nights because it is the night that the quizzes are due. So if you're at the last minute and you still haven't figured out some quiz questions, so 3, 4, and 3, 5 next week, they're going to be due next Tuesday. And so it'll be the same night that it's due. So it'll be your last minute chance of getting those questions answered before you turn them in. You got to turn them in by midnight. So, and I'm not going to be really strict on that, but I'm going to say Tuesday night. I mean, if people turn it in Wednesday, and if they make a habit of it, I will probably start counting points off, but I'm going to be pretty lenient on that stuff anyway. But you need to get them in. Well, if you guys are not going to ask me any more questions, Kristen, you have nothing else for me?
No, I'm good.
You're good.
Yep.
Haley's good. All right. So anyway, it'd be a good thing to do is while you're working on it, jot down a question, Haley. Because sometimes you have a question and then you forget about it and you forget to ask about it during the session. So if you ever do a problem, whether it's on the homework or the quizzes, just jot the problem down and then throw it at me when we open up on the session, okay? So, and that way, Because I know when I was a student, I would have a question when I was doing my homework. If I didn't write it down, I'd forget to ask the professor the next time I came to class. Sometimes I remember, but a lot of times I forgot to ask the question. So I learned when I got about a junior. It took me about 2 years to figure that out. When I became a junior, at that point, I always wrote down the question as soon as I had. I mean, and if he would answer the question in class, a lot of times they wouldn't answer the question. So they'd give you a vague response, and then you just okay. So, but anyway, that's just the way that's what it was back in the 80s anyway. So, all right. Well, I have nothing else. Christopher, you're going to talk to us before we go?
Yeah.
He said something in the chat.
Oh, who said something in the chat?
Chris said something in the chat.
Oh, let me go back to the chat. Okay. Oh, there is a chat. Oh, so he says he cannot make it to the Tuesday, Thursday. My internet isn't working right now very well. Well, then if you're going to have questions, Christopher, you're going to have to just email me, and then are you working? Do you work or okay? You say you're working. What is your hours? Seven to 10. What time do you have to leave to go to work? Is that 7 in the morning or 7 at night? Is it, so you're working 3 hours or are you working 15 hours? Oh, that's at night. So 7 at night. Would it help if I started at 6 instead of 8? Would that still give you time to ask your questions before you have to go to work? I mean, how long does it take you to get to work? Then if we open at 6, then we'll let you open up your questions first if you have them. And then when you got to go, you got to go. And then Christine can ask her questions after that. Ooh, 6:15. Just so you leave around 6:15. Oh, well, if we start at 6, I mean, you could probably, because you don't ask that many questions anyway. So if we go from like 6 to 6:15, you can get your questions answered. And then I sometimes come in here I try to come in a couple of minutes early. So, and then I get you out of the way quickly. Okay, we'll do it 6. I'll send out an email clarifying that or changing that. So 6 on Tuesday, Thursdays. And also, Christopher, the questions that the other girls ask me, I'll record them. And I'll send those out to a YouTube video so you can see what we talked about the rest of the time you left. Because I'm recording this one as well. Okay, sounds good? All right. All right, guys, take it easy. Be safe. Keep your social distancing.
Bye.
See you later.
Bye.
Bye.